Hello everybody. So in this video, I'm going to show you how to do normal distribution questions in Rguroo. So I'm going to go ahead and share the PowerPoint here and show you our first example. All right, so this is our first example. We're going to answer all of these 6 questions using Rguroo. So I'm going to go ahead and stop my share here and go to Rguroo, and let's get started here. So you're going to go under the first part of the question. So first of all, it tells us that the ages of people on the football team are normally distributed with a mean of 27 and a standard deviation of 2. We're first finding the probability of a football player being between 26.3 and 29.8 years old. So under probability calculator, continuous. So your mean is going to be 27. Oops. Your standard deviation is 2. And then, so we're looking for between 26.3 and 29.8. So we're going to put between and then put our lower value and our upper value. And then I'm going to check the graph box and then hit my eyeball here. And there we go. There's our probability right there. And so we can either go through this tab again to do it again, to do the next part, or, which is probably slightly easier, we can just hit the basics and edit it. So our mean is still 27, our standard deviation is 2. This time we're looking for the probability of a football player being more than 25. So let's do above 25. Hit the eyeball. There we go. There's our probability. And then finding the probability of a football player being no more than 20. So that's going to be below 20. Hit the eyeball. There's our probability, 0.0002. And then the graph also helps you confirm that what you did is correct, and you can also see it here in inequality notation. So that's the one direction. That's taking values of probability. Let's go the opposite direction now. So we're going to have probabilities and find the data values. For example, finding the age of a football player in the 70th percentile. So first of all, I'm going to change it to probability to values. So 70th percentile, that means 70% of the data is below the data value. So that means that we have 70% below our data value. That's our probability below the data value. So we have a lower tail, which means below the data value, of 0.7. So this means our probability below the data value is 70%, or 0.7. Then hit the eyeball, and you can see it gives you your data value right here, so 28.05. And you can confirm that your probability below that value is 0.7. So the next question asks for the minimum age that will be in the top 5% of the ages on the team. So that means that we have 5% of the data above our data value. So this time we're going to have an upper tail with a probability of 0.05. Hit the eyeball. Our data value is 30.29. And the last one, the middle 50% of the ages are between which two values. So this time we have our probabilities in the middle, not on an upper or lower tail. So we can hit between tails here. Now it gives you lower tail and upper tail. So the middle 50%, that means we have 25% on each of the edges. You can think of it as the remaining 50% is split equally between each side. So the remaining 50% divided by 2 is 25%. So our lower tail is 0.25, and so is our upper tail. Then if you hit the eyeball, it gives you your range of values here. It's 25.65 to 28.35. You can confirm that is indeed a probability of 50%. And that's it for example 1. So we're going to do 3 more similar examples here. So I'm going to stop my share and show you guys the next example. All right, so this is the next one we're doing. So very similar questions, slightly different wording, that's all. So I'm going to stop my share here and go to Rguroo, and we're going to go through all these 6 questions again. All right, so we can continue to edit just by clicking on basics here, rather than going through the whole process from the beginning again. So we're changing our mean and standard deviation now. So we have the mean height of the flowers in a garden is 15 centimeters with a standard deviation of 1.2 centimeters. And we're assuming it's normally distributed. We're going values of probability first again. So the first thing we're doing is finding the probability of a flower being at least 18 centimeters tall. So that's going to be above 18. Hit the eyeball. There we go. There's our probability. The next question, find the probability of a flower being between 20 and 25 centimeters tall. So you're going to hit between and then 20 and 25. Hit the eyeball. There we go. So this means 1.545 times 10 to the negative 5, which is 0.000. Wait, okay, let me say that again. It's 0.00001545. Let me write it on my screen here. So it's 0.0001545. So we take the decimal point, move it 5 places to the left. So that's all that means. So this is basically 0. So when you see the E, it means it's a very small number. All right, and then the next one. So we're looking for the probability that a flower is less than 13 centimeters tall. So we're going to put below 13, hit the eyeball, and there we go. And I love how it shades the area, so you can clearly see what area you are getting the probability of. All right, so now that's the probability part. Let's do the other direction now. So let's go probability to values. So the first question, we're going to find the height of a flower in which 40% of the flowers are shorter than it. So now we're finding a data value given the probability. So if 40% of the flowers are shorter than it, that means we have 40% of the data below your data value. So you're going to have a lower tail of 0.4. Hit the eyeball. And there we go. You get 14.7 centimeters. The next question, it wants you to find the middle 30% of the flower heights. So this is the between tails thing again. So the middle 30%, so that means we have 70% on the rest of our distribution. That's going to be split evenly between the 2 sides. So you're going to have 35% on each side. So 0.35 for both your lower tail and your upper tail. Hit the eyeball. You get the range of 14.54 to 15.46. And you can confirm here that that does indeed correspond to the middle 30%. And then the last part, find the height of a flower that is shorter than 30% of the flowers. So it's shorter than 30%. That means we have 30% above it. It says 30% of the flowers are taller than it. So we're going to put an upper tail of 0.3, hit the eyeball, and there we go. We get 15.63 centimeters. And that's it for that example. So we're going to do 2 more examples. So I'm going to stop my share here and show you our third example. All right, so this one we're dealing with manufacturing time of a particular product. So, and proportion means probability. So you can see proportion, percent, probability, they all mean the same thing. So I'm going to go back to our Rguroo now. Okay, so actually, no, I don't want to do that. I want to keep it because I want to edit it from here. So we're told that the manufacturing time of a particular product is normally distributed with a mean of 20 minutes and a standard deviation of 1.5 minutes. So the first thing, we're finding probability. So this first part, we're given data values. We're looking for probability. So find the proportion of products manufactured between 15 and 30 minutes. So between 15 and 30, hit the eyeball. There we go. There's our probability. So we can see it's almost the entire distribution here. That's why our probability is so close to 1. The second one, find the proportion of products manufactured in no less than 18 minutes. So that means 18 or higher. So we're going to do above 18. Hit the eyeball. You get 0.9088. Find the proportion of products manufactured in 16 or fewer minutes. So that's going to be below 16. Hit the eyeball, and you get 0.00383. So those are our probability questions for that example. Let's now start going the other direction. So the middle 20% of manufacturing times is between which two values? So now we're given probabilities. We're looking for data values. So let me switch the mode here. So we're doing between tails first. So if we have 20% in the middle, so we have 80 remaining percent that's going to be split evenly between the two edges, 40% on each edge. So your lower tail is 0.4, your upper tail is also 0.4. Hit the eyeball. You can see that your middle 20% here, it has a probability of 20%, is between 19.62 and 20.38 minutes. The next question, find the manufacturing time in which 75% of the products are manufactured faster than it. So if 75% of the products are manufactured faster, that means 75% of the data is below your data value. So we're going to have a lower tail of 0.75. Hit the eyeball, and there we go. You get 21.01 minutes. And then the last question for this example, find the manufacturing time in which 35% of the products are manufactured slower than it. So that means we're going to have 35% of the data above your data value, since slower means higher times. So we're going to have an upper tail of 0.35. Hit the eyeball, and we get 20.58 minutes. That's it for that example. We're going to do one more example in this video here. So I'm going to stop my share and go back to the PowerPoint here. All right, so this is going to be our final example. Assume the weight of people in a city is normally distributed with a mean of 150 pounds and a standard deviation of 15 pounds. We're going to answer all of these questions. Once again, percent is the same as proportion or probability. So they all mean probability. So let me go back to our Rguroo here. So I'm going to go under basics again and edit what I have. So we were told that we had a mean of 150 and a standard deviation of 15. First question, find the percent of people whose weight exceeds 170 pounds. So first of all, we're going from data values to probability. So we're going to select this option here, and then it's going to be above 170. Hit the eyeball. And so that gives me about 0.09. Which you could convert that to a percentage also, since it asks you what percent. So that would be 9.121% if you move the decimal 2 to the right. All right, the next part is the percent of people whose weight is below 120 pounds. So below 120. There we go. So you get about 2.275%. And then the last one, find the percent of people who weigh between 180 and 200 pounds. So between 180 and 200 gets me about 2.232%. So that's our probability questions. We're going to do the ones that go the other direction now. So probability to values. So find the maximum weight that would be in the bottom 10% of weight. So now we're given probability, we're looking for data values. So bottom 10%, that means we're going to have 10% below the data value. So we're going to have a lower tail of 0.1. Hit the eyeball. That gives us 130.8 pounds. The next question, find the smallest weight that would be in the top 15%. So that means we're going to have an upper tail of 0.15. Hit the eyeball. That gets you 165.5. Because top 15% meant we had 15% above the data value. That's where we got the upper tail of 0.15. And then the last question, the middle 25% of the weights is between which two data values? So if we have 25% in the middle, we have 75% split evenly across the other two, across the two edges. So 75% divided in half is 37.5. So on each edge, we're going to have 37.5%. So between tails, 0.375, 0.375. And I also have diagrams for these middle whatever percentage questions in the class notes that will also help you to visualize what I'm talking about when I say the rest of the probability is split between the two edges. Hit the eyeball. So we're going to get between 145.2 and 154.8 pounds. You can clearly see that corresponds to a probability of 25%. You can see the middle 25% here. And so that's it. So that's all the examples in this video. So that's how to do normal distribution questions in Rguroo. If you have any questions, please feel free to reach out.